Good morning to my 7th graders. This is Miss Soma. I miss you all so much, and I want you to know that you, by far, my best group of students. Please stop by my classroom. I would love to see you all when things get better and when we're finally back in the classroom. So today I will be reviewing functions because this is a certain unit that you're really gonna need and constantly revisit even in 8th grade or even in high school. I know you did well on our test on this one, but I really don't want you to forget this lesson. So I'm gonna pretend as if you really didn't know anything about functions when they are proportional or when they are additive. So I love to always start with the most basic one, y equals x. All right, so if is equal to x, so let's create our table of values. And I like doing my -2, -1, 0, 1, 2. So if y is equal to x, then it will just be the same value. All right, now let's plot our points. This is our x and this is our y. So -2, -2. -1, -1, 0, 0, 1, and 2. All right. Oh, by the way, if we don't see a value next to our x from our lesson in equations, what number is invisible there? Yes, there is an invisible number of 1. That means 1 times x. Okay, so this is our line for y equals x. Okay, so now let's try what will happen if we will have y equals to x. Okay, so we like using our -2, -1, 0, 1, 2. You can choose any value you want on your x, but I just like constantly using this one so that it will fit in our graph and you can easily see the pattern. So 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 1. 2 times 2 is 4. Now let's plot our points. -2, 1, 2, 3, 4. -1, -2, 0, 0, 1, 1. Oh, I made a mistake here. This is a 2. 2 times 1 is 2. So 1 is 2. 2, 1, 2, 3, 4. All right, so now here is our line. And that's y equals 2x. Okay, so what is common between the two lines? Yes, they all pass through 0, 0. So let's try another multiplication pattern here. Let's see, y equals 3x. Do you think this will pass through 0, 0 again? So let's find out. So we have -2, 3 times -2, -6. 3 times -1, -3. 3 times 0, 0. 3 times 1, 3. 3 times 2, 6. All right, let's plot our points. -2, 1, 2, 3, 4, 5, 6. -1, -3. 0, 0, 1, 3. 2, 6. All right. There we go. So that's y equals through x. So was our prediction right? It's still passing through 0, 0. So now, look at all this right here. Look at our functions, our equations. All right, so all of them are multiplications. 1 times x, 2 times x, 3 times x, and they all are behaving the same when they're all passing through 0, 0. Although there's a little bit of a difference among all three of them. Right here, our points are far apart, getting closer, and much closer. All right. Although we can look at points somewhere in between too that we don't know exactly how much is the value, but we could just estimate. Okay. So when you see a times pattern, we notice that it's going through 0, 0. So let's check, because we've had table of values also when we had proportions. So let's check if this table shows proportion. So we had several ways on testing proportionality. So let me go back to what we did before. So we all know that 1/4 is equal to, you know what, I want to do 1/2. So 1/2 is equal to, give me a 1/2. I'm thinking of 4/8. All right, so when you tested this before, if they are proportion, we did 4 divided by 1. So let's say 4 divided by 1, I get a 4. 8 divided by 2, it's a 4. So I know that these two fractions are equal. Okay, so now we also did 2 times what? That will give me an 8, a 4. Well, 1 times 4 is 2 times 4 gives me an 8, and then 1 times 4 gives me a 4. So that method tells me that, oh, these two fractions are equal to each other. And then we also realize that if we multiply 2 times 4 is 8, 8 times 1 is 8, so their product is equal. So we say, oh, when the two fractions are in proportion to each other, then that means their cross product is also equal to each other. So let's use that concept in testing our table of values. Let's try -6 times -1 is 6. -2 times -3 is 6. Proportion. Now let's try the other pair. -3 times 0, 0. -1 times 0, 0. Still the same. Now let's test the other one. 0 times 1, 0. 0 times 3, 0. This table is really showing proportion. 3 times 2 is 6. 6 times 1 is 6. Okay, now let's test it using our division. So let's see. And when we do that, we cannot use our 0. Remember that? All right, so let's do -6 divided by -2. It's 3. -3 divided by -1 is 3. 3 divided by 1 is 3. 6 divided by 2 is 3. So this is showing proportion. So do you think this table would also show proportion? Well, let's find out. So -1 times -4 is 4. -2 times -2 is 4. I'm just going to do a few points here. So -2 times 0, 0. Then this is 0. So they're all showing that this table of values are proportion. So let's put that here. We noticed a times pattern in the equation. So few things that we noticed. We also noticed that all the lines are passing through the through 0, 0. So tables are proportion. We also noticed that lines pass through 0, 0. So we can say that this function here is showing proportionality. Okay, so let's check what happens if we are not going to do a times pattern anymore. We're going to do a plus pattern. So let's say y is equal to x plus 1. All right. Okay. If x is -2, -1. How did I do that? Well, x is -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. All right, let's plot our points. -2, -1. -1, 0, 0, 1, 1, 2, 2, 3. All right. What did we notice from this line here to the line we had before? Oh, where was it? Here it is. This line right here did not pass through 0, 0, but this line here passes through 0, 0. Okay. And let's do our y equals x as well. So you will see it as our guide. With y equals x, it's right here. Okay. So now, let us go back here real quick, because I forgot to mention this on how the points are going up and going across. So with y equals x, or 1x, it's going up 1, going across 1. With y equals 2x, it's going up 2 times, and it's going across 1. If I will have y equals 3x, it's going up 3 steps and going across 1. All right. So did you see the relationship here? Okay. Now what happens if I would do a fraction? So y equals 1/3 x. So what is the denominator here? It's over 1. So it's going up 2 steps, going across 1. The denominator here is 1. So going up 3 steps, going across 1. So in here, this is our denominator. This is a going up pattern. And this is the going across pattern. So when you do 1/3 x, it's going to be, and remember, this is a times pattern here. So it has to always go through 0, 0. So now going up by 1, going across 3. Okay, so 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. All right, this is our y equals 1/3 x. All right, I just want to mention that one to you, and we can do more practice later on about that one. All right, so now let's take a look at our plus pattern. Okay, so this is our y equals x. This is our y equals x, but we added 1. Okay, so now let's see what happens if we will have y equals x, and then we are adding 4. Okay, so this is the change that we're doing. So at -2, so -2 plus 4 is 2. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. Okay, now let's plot our points. -2, 2. -1, 3. 0, 4. 1, 5. 2, 6. What did you notice with our lines? They're all going up by 1, across 1. Up by 1, across 1. Up by 1, across 1. So they're all going up and going across using the same pattern. The only thing different here is this y equals x, move up by 1, and look at that. How does that relate to our equation? And this is y equals x plus 4, and it also moved up 1, 2, 3, 4. All right, so let's take a guess. What would happen to our line if I will have y equals x minus 2? So it's a y equals x actually, but we're just shifting it 2 steps down. So now we will do 1, 2, and then same behavior with our graph. Up by 1, across 1, up by 1, across 1. Did you notice something among these 4 lines here? Yes, they are parallel. Because what is our slope? What is our slope with y equals x again? Our slope there is 1. What is the slope with our y equals here? Y equals x, still 1. Y equals x here, still 1. But the plus 1 here are showing us where is it shifted along the y-axis. And we talk about football being intercepted. So imagine having your ball, the football being thrown here, and it's intercepted at -2. So it's intercepted at 0, it's intercepted at 1, it's intercepted at 4. So these numbers that we added here or subtracted is our y-intercept. Where is it being intercepted along the y-axis? So our y-intercept here is -2, +1, +4, and here is 0. All right, so now if I would have to show you, oh wait, we have to check if our table is proportional. All right, let's do this one here. 0 times 3 is 0. -1 times 4 is -4. Right away, you don't even have to do any more tests. Once you test it and it's already not proportional, you don't have to test some more. Right away, it's not proportional. So let's look at the difference and let's write down our observations. When is a function proportional and when is it additive? All right, so I'm going to be showing you different functions. Okay, so let's see. Proportional or not? Not proportional. And let's look at the pattern. Going up by 1, going across 1. So let's list down our observations. When it's additive, and when is it proportional? It's proportional when it passes through 0, 0. Or the origin. We also noticed that it's a times pattern. So a times pattern. And then what else did we notice? Let's go back to our observation earlier. Tables are also proportional. Times pattern in the equation. So times pattern in the equation. And tables are proportional. All right. Now, when it's additive, what did we notice? Always going up by 1 and going across by 1. Does not pass through 0, 0. All right, so now I think that's it, unless you can add some more observations. Okay, so now I'm going to create this function right here. I'm going to go up by 1. I'm going to go across by 2. Down by 1, across by 2. I'm going to continue the pattern. So is this proportional or additive? Let's take a look. Passes through 0, 0. Oh, this must be proportional. So if it's proportional, I know this is going to be a times pattern in my equation. All right, so let's look at our slope. It goes up by 1, go across by 2. All right, so that's your equation there. And this one, this goes up by 1, go across by 1. That's my times pattern there. However, it does not pass through 0, 0. So that means it's being shifted by 1. So we say plus 1. So your equation there is x plus 1. All right, let's practice some more using that same observation. Okay. So I'm going to put a point here. I'm going to make it go up by 1, across by 1. Proportional or not? It's additive. So now y equals x. It's a y equals x pattern actually. Then we just shifted it 3 steps down. So minus 3. Let's do another one. How about this? Still a y equals x pattern. But then we shifted it 2 steps up. So plus 2. All right, now I have a question here. Well, before that, let's try this pattern first. What if I'm going to have it pass through 0, 0, and I'm going to go 4 right here. So I know this is a times pattern. So y equals, how many steps did I go up? 1. Go across 4. So 1 up, across 4. So y equals 1/4 x. Now, I have a quick question here before I will end this video. I'm going to show you a line. All right, so now I'm going to not go through 0, 0. I'm going to start here. And then I'm going to go this way. So is this an additive pattern? When is it additive pattern? Is only if it is copying the behavior of y equals x, but it's just being shifted up or down. So is this behaving like our y equals x pattern? It's not. So therefore, this is not proportional. So not proportional, not additive either. So that's some kind of functions which you will, this is some kind of functions which you will learn in 8th grade. But for now, let's make sure we understand the difference of when is a function proportional and when it's not, or when it is additive. All right, well, take care of yourself and please stay at home. Till next time, guys. Love you.